Right, sir. Online students, am I audible? Is my screen visible? Can you respond?
Yes, sir.
Right, sir. Right, sir. SW03 people, is anyone there? Can respond?
Yes, sir.
Right, sir. SW01, is anyone there? Right, sir. So I guess for SW03 and SR01, we are just completed till the apparent shift, and which is nothing but the relation between your apparent depth or the shift based upon your real depth and your apparent depth, right? So இதோட வச்சு நம்ம ஸ்டாப் பண்ணியிருந்தோம். And I don't know, like, what is the topic which is going on for SW01? Is anyone there? Please respond. Right, so no one is there. Right. So now we'll just learn about the lateral displacement of emergent beam from a glass slab. Right. So let me take a slab of some thickness T, and let it be the first normal where the light is going to be incident. The point of incidence is being of this, and let this be making an angle of I. So what happens is that it is being moving from rarer medium to denser medium. So outside the rarer medium is being R, and inside of some value. So let me take it of the mu. Now what happens? Rarer to denser போகும்போது it will be bending towards the normal, and this angle is going to be your angle of refraction. Right. இப்போ இந்த இடத்துல the second normal comes into play, and it's again moving. I mean, moving from rarer medium, denser medium to the rarer medium. So it will be bending away from the. Now, if I just extrapolate this incident ray, the incident ray as well as the emergent ray, the actual path of the incident ray and the emergent ray will be having a it will be parallel to each other, right? And this distance between the actual path of the incident and the refracted ray or the emergent ray is what we call it as the lateral displacement. So here the small d is being called as your lateral displacement. Now, in the angular, let me take it as the angle of emergence, right? And what about this angle with respect to your incidence? I can write this as I minus R value. And whatever the refraction which is being going on here, this will be your R dash value. Right. Now, at this region, that has been, it's coming from glass to air. So I can write it as mu2, aதாவது mu2 is air divided by the glass will be equal to your sin I divided by sin. Correct. இங்க I என்னது R என்னது? I is your R dash value and R is your E value. Correct. So and also we know that R is going to be R dash value. So interior and opposite angles. Correct, sir. So இதை நான் எப்படி எழுதலாம்? So mu of A into sin R will be equal to mu into sin R value. So R is going to be one value. Am I right? So I can write this as your sin I is going to be your sin emergence value. So since the angles are being small, I can write it as your angle of incidence is equal to angle of reflection. This is the proof that what over the emergent line has been there, it has been moving parallel to your incident. Right? Now, what about the thickness? It's just a proof. Either don't spend more time on this. Now, next comes your lateral displacement. So this is going to be the lateral displacement. So நான் என்ன பண்றேன்னா இதுக்கு இந்த perpendicular line இப்படி வரையறேன். என்ன சார்? sin I வந்து என்ன சார்? இந்த இதுல சொல்றியா? R is equal to R dash value, right? And what about this angle? This is the angle of deviation. So sin I minus R னு வருமா? Right? And what about here? Mu of R is being 1 and R dash is equal to R னு சொல்லியாச்சு and R is equal to your emergence ray for this part. Now, மேல இருந்து வரும்போது எப்படி வந்திருக்கும்? இங்க air to glass வரும்போது sin I by sin R will be equal to mu by 1 ன்னு இருக்குமா? இப்போ இதையும் நான் கம்பேர் பண்ணலாம். Right. Now, next comes your D value. That is your lateral displacement. So let me take this perpendicular line as this point is P and this point is Q. Okay, va? In the motta emergent ray, it has been starting from A and the emergent ray, the point is been of your P. And the point of incidence here, let it be O. Now, lateral displacement is equal to PQ dana. So the PQ1 I will OP sin I minus R. Correct, sir? Sin I minus R na enadhu? Opposite by hypotenuse. What is the opposite? This is your PQ value. So PQ divided by this is the OP. Sorry, O and P. Right? So this will be the case. Any doubts here? No. I can write this as OPS. O. And where is the point here? In the perpendicular line, அப்படியே extend பண்றேன். இது M ன்னு எடுத்துக்கிறேன். Right, sir? Now, OP I can write it as OM by cos R value. Correct, இல்லையா? Cos R is nothing but OM by OP. So OP வந்து OM by. ஏன்னா நான் வந்து OP ன்றது வந்து it is of a hypotenuse which has got nothing. Right? எனக்கு தெரிஞ்சது thickness மட்டும்தான். So thickness வந்து யாரு? O m one தான் எனக்கு thickness. Correct? So OM thickness I can easily take it out into இந்த இது அப்படியே தான் இருக்கும். Sin into I minus R value. Right, sir? So அப்ப ஆக மொத்தம் what is your displacement is going to be, that is your lateral displacement is going to be of your OM. OM is the thickness of the slab into sin I minus R divided by cos R is the value. This is going to be your lateral displacement along a rectangular slab. Any doubts here? புரியுதா? This is an expression, and this is your question based on this. Parallel sides of glass slab of thickness is 6 centimeter, made up of material is refractive index is √3. When a light is incident on one of the parallel faces at an angle 60 degree, it emerges on the other side, other parallel face. Find the lateral shift of the emergent. Hello, sir. Yes, sir. So you have got the thickness, incidence எவ்வளவுன்னு கொடுத்துட்டோம். Only thing R first கண்டுபிடிக்கணும். Refraction direct அவன் தரல. How do you find this out? Yes, sir. One point. What is the R value? Correct, sir. How much? 3√3. Okay, they are given 2√3. Right, okay. Right, sir. So what about your displacement is equal to thickness into sin I minus R divided by cos R is the value. Now, so in incident R, it has been making an angle of how much? 6 is your R value. And this is the refractive index. Correct? So this is sin 60 divided by sin R will be equal to mu2 by mu1, which is nothing but √3 is the case. Now, sin R will be equal to sin 60 is how much, sir? √3 by 2. So sin R will be equal to 1 by 2. No, R will be equal to 30 degree. Now, T is 6 into, yes, sir. Get it, sir. Sin of 60 minus 30 divided by cos 30. Now, sin 30 is 1 by 2 and cos 30 is √3 by 2. So 2 and 2 will get cancelled. You will get it as 6 by √3. Factorize panina 2√3. So 2√3 centimeter is your answer. Right? Now find out the case for this. Find the lateral shift of a light ray when it's passing through a parallel of glass. Thickness is 10 centimeter, placed in R. The angle of incidence in the R is 60 degree. Angle of refraction in glass is 45 degree. Only thing you have to write the D value. What is the expression? D is equal to thickness into sin I minus R value divided by cos R. So which is of 10 into I minus R. So 60 minus 15 is sin 15 degree divided by cos R is 45. So √2. So 10 √2 Sine 15 degree centimeter is your answer. Right? Here they haven't converted this 15 degree. So this is how you will be solving it for the lateral displacement when it's been placed for a rectangular slab of the parallel faces. Right, sir? Okay. இது எல்லாத்துக்கும் bookல இருக்கா? I mean, apart from the NCERT. Rectangular slab. Rectangular slab, yeah. Refraction in a glass slab is being given for the state board, right? And this is also for the JE purpose. So this is how the thickness is being and the lateral displacement based upon the thickness, right? Now, when you are the same cases, when you are considering about the smaller angles, that is the special case is that I and your angle of refraction is being for the smaller angle. If you consider for the small angles, then sin I by sin R is equal to mu 2 by mu 1 varum. So I can write it as I by R will be equal to mu by 1. Considering that the ray is being traveling from rarer medium to denser medium. R lendo or glass medium, so it is been of your refractive index. Right. Now how comes your refraction case? ரொம்ப ஸ்மால் ஆயிருச்சுன்னா என்ன ஆகும் சார்? Your displacement T into sin I minus R, I can write it as I minus R. And what about cos? Sino, tan, it will become smaller, means it will be. Then what about cos? 0. Cos 0 is 1. So this is the answer for the lateral displacement if you are considering for the smaller angles. Sir? Right. In terms of the refractive index, I'll just give that also. I a common, you will write it as I into T 1 minus R by I value. Correct, sir? R by I is 1 by mu. I by R is mu. Then R by I is mu. 1 by mu. So I can write it as your lateral displacement will be equal to I into thickness into 1 minus 1 by mu. This is with respect to refractive indexes. And the special case, what is that? When I and R smaller angles are. Any doubts here? Next comes your one of the important derivation for their boards, that is refraction from a spherical surface. A light is being traveling from denser medium, rarer medium to the denser medium. So this is a denser medium, and this is going to be your principal axis. Right? So I just kept an object here. Refractive index, either N1 no, either N2 no. Let me take it as. So where your N1 is rarer, and this is your the denser medium. Now, this is the first angle of incidence, right? In the incident normal where it will be meeting at the center of the curvature of this particular point, correct? So now extend this is the normal about this point. So they'll be meeting at where, sir? C. Right. Rarer to denser portion, it will be bending towards the normal. So this is the line which your refracted ray is being off. So either one, let me take it as I. The image which is being formed over. Now, this is going to be your pole. polar this is your image distance, sorry, object distance, and V is your image distance, and from here center of curvature is your R distance value. Correct, sir? What are the angle which is being subtended here? So we are just going to take up the angles. So let the angle made by the incident ray of the object with respect to principal axis, let it be alpha value, right? And center of curvature either beta or and with respect to image, let it be gamma value. And we already know that aperture we have been taking it as a smaller aperture. So let this be your normal n, right? அப்ப இதுக்கு என்ன பண்ணுவோம்? இதுக்கு perpendicular ஒரு line வரைஞ்சு, shall I make this point as m? So almost your center of curvature pole center of curvature m it will be having the same distance since the aperture has been so small. So CP almost equal to your CM. Right, sir. Now, what about the triangles? So triangle your NOM. Okay. Right, sir. Now this will be the angle. Oh, sorry. NO and C. N, O, and center of curvature. This is your alpha, and this is your beta. Correct, sir? Now, in the line, extend pannu vechukko. This is going to be your exterior angle, right? That is nothing but your என்ன ஆயிருக்கும்? Angle of incidence. இதை நான் theta 1 எடுக்கிறேன். So sum of interior angles will be equal to your exterior angle. So I can write it as alpha plus beta is equal to theta 1. Let it be the first triangle. Now, next யார் எடுப்போம்? C, sorry, N, I, and C. So triangle NIC. இது I, இது C, இது N. And this angle is your gamma. Correct? Next, what about your this angle? இது என்னவா இருக்கும்? Angle of refraction. So let me take this as theta 2. எடுக்கலாமா? Interior angle will be equal to your, what about the beta, sir? Beta எந்த இடத்துல இருக்கும்? இந்த இடத்துல இருக்கும். Correct? So theta 2 plus gamma will be equal to your theta. So this is your first triangle and this is your second triangle. Right? Next நம்ம என்ன எடுப்போம்? Write your in triangle NOM. Tan alpha will be equal to, what is tan alpha, sir? NM by MO or MP, right? So MN by O. Correct? And this has got some height. So let me take here it is MN is equal to some height H. So these are the assumptions we have been applied. அப்பனா இது எப்படி எழுதலாம்? H divided by, what is the distance, sir? Object distance. So you'll be writing it as minus U, right? Next, அடுத்த triangle என்னது? In the triangle of your NMC. Triangle NCM. NCM. What about this angle? This is beta. This is sir? R, and this is your H. So tan beta will be equal to H divided by R. That's plus R because that is a concave surface. Right? Now, next comes your tan gamma value. Gamma value enna? In triangle NIM. NIM. இது I, இது M, இது N. And this is your gamma value. Tan gamma will be equal to M learn image vara enna sir? V. And this is H. So H by plus V minus V plus V because it's in the opposite direction of your V. Now alpha kandupidichachu, beta and all the angles are smaller angles. So we'll be taking it as alpha, beta and gamma. So since alpha, beta and gamma are the small angles, so what are the equations you are getting it, sir? Alpha plus beta is equal to theta 1 and theta 2 plus gamma is equal to beta value. Correct? Now comes your Snell's law. What is your Snell's law? Mu2 by mu1 is equal to sin I by sin r. Sin I na another theta 1, sin theta 2. So sin theta 1 divided by sin theta 2 will be equal to n2 by n1. Angle smaller na solten. Angle smaller na enna agum? Theta 1. So theta 1 into n1 will be equal to n2 into theta 2. Correct, sir? What is theta 1 in terms of alpha and gamma? Theta 1 is alpha plus beta. So write this as alpha plus beta, which will be equal to n2 into theta 2 enna value, sir? Beta minus gamma. Alpha, beta, gamma ella value me theriyuma. Substitute it here. You will get it as n1 common edutittu h by minus u plus h by r, which will be equal to n2 h by r minus h by b. Now all the h will get cancelled out, right? So ultimately by rearranging the term, you will get it as n2 minus n1 divided by r will be equal to n2 by v minus n1 by. So this is your equation whenever a light is being traveling over, refraction taking place at any spherical surfaces. So n1 is the light comes from, and n2 is the light that goes to, right? ஏன்னா நம்ம இந்த மாதிரி ஸ்பெரிக்கல் சர்ஃபேஸ் ரேரர் டு டென்சர்னு எடுத்தோம். இதே டென்சர் டு ரேரர் எடுத்தீங்கன்னா அப்ப என்ன பண்ணுவோம்? இதே தான். பட் தி திங் இஸ் தட் யூ ஹேவ் டு கன்வெர்ட் த சைன்ஸ் அலோன் uv டைம். பட் ஃபார்முலா ரிமைன்ஸ் த சேம். எது n1 னா என்ன, அதனால தான் நான் இங்க மென்ஷன் பண்ணேன். n1 னா லைட் கம்ஸ் ஃப்ரம். ஸோ இதே இது வந்து உள்ள இருந்து வெளியே வந்துச்சுன்னா இப்போ யாரு டென்சர் மீடியம் ஆக்ட் ஆவா? டென்சர் மீடியம் இஸ் த ஒன் வேர் இட் வில் பி இன்சிடென்ட். அப்ப அது n1 ஆயிடும், ரேரர் மீடியம் வந்து n2 ஆயிடும். ஸோ டைரக்ட் எக்ஸ்பிரஷன் ஃபார் இட். Any doubts here, sir? No doubts? No. Next comes your thin lenses. So what are the types of, so here we'll be studying about the types of lenses, and from there how the lens makers formula comes in, and lens maker formula derivation பார்ப்போம். அதுல இருந்து how the questions have been asked, right? So first thing is about their types. So this is your concave lens. And this is going to be a convex, right? Next comes your plano concave. So one surface will be plane and the other surface will be a concave surface. So something like this, right? அப்ப இங்க என்ன ஆகும்னா this will be having some radius r and the plane surface will be having the radius is infinity. Plane mirror ஓட radius of curvature என்ன? Infinity, right? Whenever there is a plane mirror, I mean the plane surface, the radius of curvature will be infinity. Now similarly here, the plano convex. So same goes here. One side is a plane and the other will be side will be having a convex mirror like this. இங்க என்னது இந்த இதுக்கு வந்து r will be equal to infinity and here comes your radius will be having some r value. Next, convexo concave mirror. So convexo concave mirror na the same thing. இங்க வந்து ரெண்டுமே வந்து it will be having some radius. ஒரு பிளேனா இல்லாம it will be having but different radiuses will be having. So it will be curved inward something like this. And அதே மாதிரி இதுவுமே இப்படி curved ஆயிரும். Right? So this is your convexo concave mirror. Now similarly here you have concavo convex lens. So இங்க எப்படி இருக்கும்? The thickness, only the difference is that middle ல வந்து it will be having a more thickness, right? இந்த இடத்துல வரும்போது meniscus மாதிரி ஃபார்ம் ஆகும். Meniscus in the sense like of a crescent மாதிரி ஃபார்ம் ஆகும். So this is your convexo concave lens. So these are the common types of lens which we'll be dealing out with. So only thing is that you have to know about which has got the radius. I mean the what about the radius? Whether எதுக்கு வந்து பாசிட்டிவா இருக்கும் and எதுக்கு வந்து நெகட்டிவா இருக்கும்னு we have to just check for it. No. Now the laws of image formation. Same as that of your mirror. Only thing is that mirror la same side form ஆகும் as well as the behind the mirror. But when it comes to lens, it will be refraction takes place, right? So எல்லாமே வந்து it will be forming on the other side. And one more special case is there when you are keeping between optical center. Now this time we will be calling this as the center of lens as the optical center, right? So when a light passes through optical center, which has been represented as capital O, the light goes undeviated, right, sir? This is the difference. So first one on the convex lens, and the other one is about the and this is about the concave lens. And look at the center of curvature. In the center of curvature, first will be this other iron, right? And whenever it will be passing through its optical center, the light goes undeviated, right? Now, next comes is about its principal axis or the principal focus. Principal focus. Principal focus. So the all the lens has got two types of focus. One on the f1 and the other one is f2. Right? And the f1, f2, எப்படி கண்டுபிடிக்கிறதுனா, here the case is that always the first principal focus is the position of the object on the principal axis. So I'll write it as PA. PA denotes the principal axis. For which the image is formed at infinity. So object ஒரு இடத்துல வைக்கணும் in such a way that அதோட image should be formed at the infinity. So first எதுல வைப்போம்? Object is being kept at the focus. Focusல வச்சோம்னா image will be met at the infinity for a convex lens. Concave என்னது? It will be formed at the, so usually concave is nothing but what is about its nature? யாரு converging, யாரு diverging? Convex lens is a diverging lens and converging lens, and concave lens is a diverging lens. So நீ என்னதான் இப்படி கொண்டு வந்த it appears to meet at focus but it will never meet at focus, right? அப்போ இங்க appears to meet na its image will be formed at infinity, image of that object, right? Infinity la தான form ஆகணும். So this is what the case is been of. So always see ரெண்டு சைடுமே என்ன f1 ஒரே சைடா இருக்காங்க? No. So for convex lens f1 f2, but when it comes to concave lens f1 is on the other side and f2 will come first. Now this is about the secondary principal focus. In this case, what happens, sir? So secondary principal focus, I mean, we call it as the secondary principal, is the primary, the first focus, and this is about the second focus, which is of f2 is the case, right? So this is the f2 ன்றது யாருன்னா, it's the position of the அங்க என்னது object, இங்க position of the image on principal axis. அப்போ principal axisல form ஆகுதுன்னா the object will be at the infinity when the object is at infinity. Right, sir? And always, so this is your the second focus, and this is your first focus. நம்ம எப்பயுமே எந்த ஃபோக்கஸை எடுப்போம் when you are drawing the image formation by concave and convex? We'll be considering the f2 தானே நம்ம எடுப்போம். இங்க இருந்து போற இமேஜ் இப்படித்தானே எடுத்திருப்போம். parallel வந்துச்சுன்னா where it will be meeting அப்படின்னு சொல்லிட்டு we won't be keeping the object as a point object at here, right? So always your f2 will be remaining as the your principal, the primary focus. புரிஞ்சுதா? So f2 is being considered as the principal focus of the lens. Right? புரிஞ்சுதா? இந்த நோட்ஸ் நான் இது முடிஞ்சோடனே அப்லோட் பண்றேன். only thing you should know about the concept. Right? டயக்ராம் வரையிலன்னு பிரச்சனை பண்ண கவலைப்படாத. I'll give the notes. Only thing is about you should know about the concept. Right? Now, the third one is about the aperture. Aperture na என்னது? It is called as the effective diameter of the lenses, right? And always this effective diameter or the aperture will be depending upon the intensity. So intensity, whenever the light is being falling it, right? என்ன ஆகும்? Based upon the number of rays only, the image will be formed. Number of rays கம்மியா இருந்துச்சுன்னா image வந்து form ஆகும். But the thing is that the intensity will be quite less. So there is a 9th or 10th there will be one question based upon it. If I just cover the half of the convex lens or the half of the concave mirror, what happens to the image formation? What happens? Image form ஆகாம போயிருமா இல்ல அரை image தான் form ஆகுமா? Image, full image will be formed. But only thing is that its intensity will get decreased. Right? Okay. So intensity will be directly proportional to square of your aperture. Right, sir? Now, இதெல்லாம் தான் the properties of lenses. What are the types of lens and lines? Lensesல என்னென்ன parts are being, parameters are being there. Principal focus, the focus are there. Two types of focus are there. One is principal first focus and the other one is second focus. Always second focus is being considered as the principal focus, right? And whenever light is passing through the there is something called as the optical center. When it's passing through it goes undeviated. Now, இதெல்லாம் base பண்ணி தான் next comes the one of the important derivation which we call it as the lens makers formula. We already know the lens formula. What is the lens formula? 1 by f is equal to 1 by v plus 1 by u. அதுதான் இப்ப நம்ம derive பண்ண போறோம். So that's what we call it as the lens makers formula. So it tells about the relation between the focus, the focal length to the refractive index. Ri denotes the refractive index of the material and the radius of the curvature. So let me have a convex mirror, right? And this is the principal axis, which is passing through the optical center. So here I'm just keeping an object, and the first thing is there. So surface, இது first refracting surface இருக்கும், இது second refracting surface இருக்கும், right? Now, for the first refracting surface, இந்த இடத்துல hit ஆகுதுன்னா, there will be something called as its center of curvature for the first surface. கரெக்டா? என்ன ஆகும் இது? இது இங்க வந்து somewhere here form ஆகும். This is your I1. Image formed by the first surface. Right? இந்த I1 வந்து, okay, இன்னும் நல்ல பெருசாக வந்துக்கிறேன். Somewhere here. This is the image formed by the first surface. Now, this I1 will be acting as a virtual object for what? Second surface. Right? அப்ப second surface na இப்ப எங்க இருந்து லைட் போகும்? I1 ல இருந்து இப்ப லைட் வந்து second surface க்கு போகும். Right? Keeping this as the second surface, so we know that இந்த இடத்துல ஹிட் ஆறத வந்து we call it as the so normal 1 and normal 2 of your second surface, and either on the center of curvature, so we will be calling it as C2 value. Right, sir? Now, next comes the refractive indexes. Let this be N, M, N of the medium and N of the lens, and again வெளியே வரும்போது N of the medium. Correct, sir? Now, இதை நான் தனித்தனியா நான் வரைகிறேன். First only about the, so for first refracting surface. So this is the object. It will be falling here. And இதோட center of curvature இங்க இருக்கும். And this is your C1 value. Right? And இங்க இருந்து refract ஆகிறது இங்க போய் விழும். And this is the image formed by the first object. Sorry, the first surface. So this is U. And this will be your V value. Correct, sir? So U வந்து சேமா தான் இருக்க போகுது. Now V is the one which will be changing with respect to it. So shall I write this as V dash? Now, how you apply it? So we already know the expression. What is the refraction or relation? The refraction at the spherical surfaces. N2 by V minus N1 by V. N1 by U will be equal to N2 minus N1 by the radius of curvature. Correct? Now we are going to supply like root for what? யாருக்கு? First surface. First surface na N2 இப்ப யாரு? This is your NM medium and this is your NL medium. Lens ஓடுது. Correct? So how will you write it? NL divided by V dash minus NM divided by U, which will be equal to NL minus NM divided by R value. So let it be the first equation. Now, similarly for the second refracting surface. Second refracting surface, directly you tell me the equation, sir. What is the equation? இப்ப எங்க இருந்து எங்க வருது? The same goes here from your lens, mediaத்துல இருந்து திரும்ப லென்ஸுக்கே வருது. So, wait. Lens to medium, sorry. Yeah. So it will be having the consideration of NM divided by. இப்ப second image, இதுதான் வந்து உன்னோட final image distance. So I'll be writing it as V minus NL by U. Sorry, V dash. V dash. Right? ஏன்னா second surface க்கு இவன் தான் object act ஆகிறான். அப்ப இவனோட object distance தான் நான் எழுதணும். V dash will be equal to, tell me sir, NM minus NL divided by your radius, which is of R. Now, இது வந்து ஜெனரலா நம்ம எழுதிட்டோம். ஓகேவா? Is it always the radius will be same? சேமா இருக்குமா? ஈக்வி கான்வெக்ஸ்னா சேமா இருக்கும். அதை தவிர வேற ஏதாச்சும் இருந்துச்சுன்னா வேற சர்ஃபேஸ் தான் இருக்கும். So shall I rate the first radius as R1 and the second refracting surfaces R2. வேற ஏதாச்சும் மாறுமா இதை தவிர? No, V dash எல்லாமே அப்படியே தான் இருக்கு. Now this will be your second equation. Now adding 1 plus 2. Even you cancel ஆயிடுவானா? Minus plus and minus. Now you will be writing it as Nm by V minus Nm by U will be equal to Nm minus Nl. Oh, sorry. So Nm minus Nl by R1 plus R2 plus Nl minus Nm by R. So by again rearranging the value, all the Nm will be taken to the one side, and you will be writing it as Nm, which is of 1 by V minus 1 by U, will be equal to N. L minus M common எடுத்துட்டு I can write it as 1 by R1 minus 1 by R. Right, sir? இந்த N அந்த சைடு கொண்டு போயிடலாமா? கொண்டு போனா என்ன ஆகும்? Yes, sir.
So that V மட்டும் எங்க இருந்து வந்துச்சுன்னு அந்த மொத டயகிராம்ல காட்டுறீங்களா?
எந்த வீடா?
கான்வெக்ஸ் லென்ஸ் செகண்ட் ரிஃப்ராக்டிங் சர்ஃபேஸ்ல V ன்னு கொடுத்திருக்கீங்க. அது மொத டயகிராம்ல எங்க இருக்குன்னு மட்டும் காட்டுறீங்களா?
This is the final image which will be formed. This is your V, sir.
Okay, sir.
This is your V dash.
Okay, sir.
This is your. Right. Right, sir. Now, take it to the other side. So you will get it as 1 by V minus 1 by U will be equal to N L minus Nm minus 1 into 1 by R1 minus 1 by R2. Now this is nothing but your refractive index. Second medium divided by first medium. So which is nothing but a mu relative, or you just keep it as it is. Now the thing here is that if the object is at the infinity, that is U will be equal to infinity, then image will be formed at infinite length on this image will be formed at the focus. Therefore V will be equal to F value. Correct? 1 by infinity 0. 1 by V I can write this 1 by F. So 1 by F will be equal to N L. So or else I write it mu 2 by mu 1 minus 1 into 1 by R1 minus 1 by R. This is your lens maker's formula.
Sir, R1 and R2 won't be the same.
No, ma'am. Like either R2, R2, like it depends upon the lenses. If they are giving equiconvex lens, then it has got equal radius of curvature. Not. I'm just making it for the general term. It can be different, right? Ab R1, R2 same arrangement, it will become like 0. So focal length will be infinite.
Okay, sir.
No. So this is your famous lens maker's formula. Right. Second medium, lens medium. Light எங்க இருந்து எங்க போயிருக்கு? வெளில தானே போட்டிருக்கேன். வெளில இருந்து தான் லென்ஸ், மீடியத்துல இருந்து தான் லென்ஸ் போகுது. So now from this one. Let this be equation 3 and let this be equation 4. Now from 3 and 4, I can derive it as 1 by f will be equal to 1 by v minus 1 by. இதுதான் உன்னோட லென்ஸ் மேக்கர்ஸ் ஃபார்முலா. நீ எழுத போகும்போது தயவு செஞ்சு one. Here I just written only the expressions. You have to write it in your words first. One is the refracting surface. So image formed by the first refracting surface is I, which is kept at the distance v dash. அடுத்து v2 and from the equation. ரொம்பலாம் எழுத தேவையில்லை. I guess they might be asking for 5 marks or something like that. Right? So this is your lens makers formula. One more thing about the lenses. I guess you know about the focal length. So focal length will be positive for what lens, sir? Convex lens. And similarly, focal length will be negative for the concave lens. Right? This is the question for you. The radius of curvature of the faces of double convex lens is being 10 centimeter and 15 centimeter. Now, is the R1, R2. If the focal length is being 12 centimeter, what is the refractive index of the glass? So this is a convex lens, right, sir? Now, if convex lens na idan convex lens, correct? First surface ku radius inge da irukum, so this is R1 plus R1. Now, what about the second surface? Idoda radius வந்து இங்க இருக்கும், which is of R2. அப்ப R2 என்ன value? It will be having a negative of the value. Now, what is 1 by focal length? So 1 by 12, correct? Which will be equal to mu lens by the mu medium. So I can write this mu minus 1 into 1 by R1. 1 by R1 na evlo, sir? 1 by 10 minus of 1 by minus 50. So here the mu value you have to find it. So check whether the mu you are getting it as 1.5. The answer. Right? புரிஞ்சுதா? இதே தான் JEக்குமே வரும். The same thing. Only thing direct application of this. இதே மாதிரி combination of lenses இருக்கு. அது நம்ம அடுத்த இதுல பார்ப்போம். Now this one. a biconvex lens has a focal length 2 by 3 times the radius of curvature of either side, either surface. Calculate the refractive index of lens material. So mu value you have to find it out. But here they haven't given the direct R value. Relation between R and F they have given. Yes, sir. Anyone? Huh? 2.3 illada. 1.75 is correct answer. Right. So biconvex lens. Biconvex lens na enna artham? They both have got the convex lens, but both have got the same radius. R1 will be equal to R2 is the case. Right? Biconvex சொல்லுவாங்க இல்ல equiconvex சொல்லுவாங்க, equal radiuses. Right? Okay. Now, so focal length is equal to 2 by 3 times the R value. Correct? Now, we know the relation. 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2 is the case. Now, focal length is, I can write it as 2R by 3, which will be equal to mu minus 1 into first surface என்ன sir, plus or minus of radius of curvature plus minus of minus R no. Correct? So we'll get it as 2R will be equal to mu minus 1 and this will be 2 by R and 1. R and R will get cancelled. So from here you will get 3 by 4 will be equal to mu minus 1. 3 by 4 is 0.75. So mu will be equal to 1.75 is the answer. So this they have asked in 2010. Any doubts here? This question, 2022. Focal length of the convex lens is being made up of a refractive index 1.5 is 20 centimeter. What will be its new focal length when placed in a medium of refractive index 1.25? Is focal length is positive or negative? What does it signify? So you have to compare it. Initially it is at the made of glass refractive index at air. If on the glass lens like any some other medium which has got the 1.25 as the refractive index, then what will be your new focal length? Will it be positive or negative? Positive are what it signifies, negative are what it signifies. Right. Only SR01 online students respond. Aditya? RS? 8 order. Either a focal length. No, sir. Not it. Aris, Afa,
Yes, sir.
right ma'am. Ajay Joshua present, Ajit V present, Akhilesh, Arun Bharati present, Hari Krishnan,
Yes, sir.
right sir. M. Harish, Harish Kumar present, Hari Varshan,
Present, sir.
right sir. Aishwarya, Jivit, Jay Saravanan, Jeevataran present, Josiah Moses, Kirti Sri, Yoga Prasanna, Mithun present, Saifuddin present, Muthu Selvam, Muthuvel present, Naresh present, Nakshatra, Padma Vinita,
Present, sir.
yes ma'am. Pranav Lakshman,
Sir, Nakshatra present, sir.
Nakshatra present, right ma'am. Pranav Lakshman, are you there? No. Sai Nathan, Ritika,
Present, sir.
right ma'am. Roslyn,
Present, sir.
Danyasri, Sabrinathan, Santoshini,
Present,
M.
sir.
Sami, yes ma'am. M. Santosh,
Present, sir.
right sir. Shiva Ganesh,
Present, sir.
Shiva Santosh, Srinikesh, Srinivasa, Sushant, Tanish
Present,
present, Tarun. Who is this sir? Sushant present,
Present, sir.
yes sir. Tarun Krishna,
Yes, sir.
yes sir. Tushya Balaganesh,
Present, sir.
right sir. Vasumati, Venkatesa, Vinoda,
Present, sir.
yes ma'am. Vishahan,
Present, sir.
Yalini,
Present,
Zenita, Yalini, okay. Zenita,
Present, sir.
right ma'am. Right sir. So in the இடத்துல வந்து they haven't given the radius of curvature, right? Only thing we have to deal out with the focal length. Now whenever the focal length, if you are immersing in some liquid, the total combination of focal length change ஆகுமா ஆகாதா? Change ஆகும்ல. Lens தனியா airல இருக்கும்போது okay. When it is immersed in any of the liquid, then the total overall focal length will be changing with respect to that. Now what I will going to do here is that now 1 by focal length. Now this focal length is nothing but when it is kept at r will be equal to mu of glass divided by mu of air minus 1 into either அதே தான் 1 by r1 minus 1 by r2 because I don't know about the radius. Now what is mu of the glass? 1.5 இதான கொடுத்திருக்காங்க. And what about the focal length? 20 centimeter. So 1 by 20 will be equal to 0.5 1 by r1 minus 1 by r2. Now similarly this is for the first case. What about the second case? When it is immersed inside the liquid, yaar first medium, yaar second medium? Glass lens vandu second medium, first medium vandu that liquid, whatever it is been of, right? So 1 by focal length in that medium will be equal to mu2 by mu1. Mu2 ன்றது வந்து இப்ப refractive index of the glass divided by 1.25 minus 1 into 1 by r1 minus 1 by r. Now tell me 1 by r1 1 by r2 அது எப்படியும் சேமா தானே இருக்க போகுது. Divide these two equations. So this will get cancelled out. So from here you can directly find out your Fm value, right? Okay, so Fm will be 0.5 into 1.25 divided by 0.25. So which is around 2.5 diagram. So focal length of this medium when it has been immersed in it, that motta system சேர்த்து it has been plus 2.5 ன்னு வருது. What do you mean? Now next comes whether it is positive or negative. Positive ன்னு வருது. And we have got the nature. எது வந்து focal length negative வரும்? Convex or concave? Concave. Then what nature is that? Converging or diverging? Diverging. Here it is positive lens. Positive lens now. So convex lens இல்ல இந்த மொத்த மீடியமே they are acting as a converging area. So it will be considered as a converging lens since the focus is being பாசிட்டிவா வந்ததுனால இந்த மொத்த சாரி ஃபோக்கல் லென்த் இஸ் பீன் பாசிட்டிவா வந்ததுனால. Now what else is there? Yeah, what does it signify that this is the case? It will be considered as a converging lens.
சார்
Yes sir.
சார் அதை டிவைட் பண்ணும்போது லெஃப்ட் ஹேண்ட் சைடுல எஃப்எம் பை 20 இருக்குங்க சார்.
எந்த இடத்துல சார்?
சார் ஈக்குவேஷன் 1 and 2 டிவைட் பண்றீங்களா சார்?
எஸ் சார்.
அப்ப எஃப்எம் வந்து நியூமரேட்டர் போயிடும், டிவைட் பை 20 இருக்குங்க சார்.
ஓ ஓகே. ஸோ இந்த இது கரெக்டாக 0.5 1.25 1. Okay, 20 should be multiplied. Correct sir. So right. Then it will be plus
50 centimeters sir.
Correct sir. Right sir. Right sir. Then this one sir. Plano convex lens mu is equal to 1.5 has a focal length of 18 centimeter in r. Calculate the radius of curvature of the spherical surface. R value. Nine is the correct answer, sir. So 1 by 18 will be equal to 1.5 minus 1 and 1 by first surface near series, second surface at series, 1 will be infinity and minus of other surface will be opposite of the turns, no? Minus of r no. So from here you have to find out your r value. So r will be equal to plus 9 centimeter. Right? This is more of like a derivative question. Write the lens maker's formula and use it to obtain a range value of mu, for which the focal length of an equiconvex lens are kept in R. Equiconvex lens means R1 will be equal to R2. Kept in R would have a greater magnitude than that of the radius of curvature of its two surfaces. So you have to find out the value of in the mu or range. How can we find this out? So the range has to be such that focal length of the equiconvex lens should be greater than the magnitude of the radius of curvature. Then அப்போ அந்த mu value எவ்வளவா இருக்கணும் அப்படின்னு கேக்குறாங்க. The general equation which you have been writing it this. Am I right? This is your focal length value. General expression 1 by f is equal to mu2 minus mu1, which is mu minus 1 into 1 by r1 minus of minus 1 by r2, because it is a equiconvex lens, right? So here it has to be, the focal length has to be greater than your magnitude of your R value. அப்போ mu ஓட வேல்யூ எவ்வளவா இருக்கணும் அப்படின்னு கேக்குறாங்க. கரெக்டா? ரைட்? That means 2 times mu minus 1 should be less than 1. Correct? Next. Right side. So mu minus 1 will be less than 1 by 2, which is 0.5. So mu will be less than 1.5 is the case. Correct, sir? So it has been refractive index of the medium, which has been kept in R and soltanga. Up R order refractive index evlo 1. The range should be falling between 1 to 1.5. This they have asked in 2016. So derivative marium they might be asking. Only thing is about the equations. Right. And most importantly, the derivations for the lens maker's formula. சில assumptions எடுத்ததுனால மட்டும்தான் we have just got this equation. The first one is about the lens. Lens வந்து it has to be thin initially. So thinna இருந்தா மட்டும்தான் this will be applicable. இல்லைனா this lens maker's formula will not be applicable. Lens should be thin. Then next comes up your aperture. அதே மாதிரிதான் aperture should be smaller. Next இங்க வச்ச object. Object is extended body or a point object. So object is a point object. And that should be kept over a principal axis la irundha mattum this will be applied. And next comes with the angles. எல்லா ஆங்கிளுமே smaller angles. Incidence ஆ இருக்கட்டும், refraction ஆ இருக்கட்டும். So only then அப்பதான் இந்த equation வந்துச்சு first. Right? இதே தானே நான் இங்கேயும் derive பண்றேன். Right? All the angles are smaller. So this is all about your lens maker's formula and your lens formula. Right? Okay, sir. So மீதி இதை வந்து we'll see it after the right, sir. Online students, you can leave the meeting. Second link I will be posting in the same WhatsApp group. Right? You can join it.